All right, so this is beginning algebra, and we're going to start in chapter 1, section 1.1, where we're going to evaluate expressions. If we remember stuff from previous classes, we talked about um, expressions as a definition. Expressions, in its simplest term, is a math problem without an equal sign. We have different types of expressions. We have numerical expressions, where it's just dealing with numbers exclusively. And we have algebraic expressions, where we have at least one variable that is in the expression. Variable is a letter that's used to represent one or more letters. So as we get into the different types of algebraic expressions, here is a little table of what they all mean. So on the very left is a type of algebraic expression, and in the middle is how it would be said in words, and in the far right is the operation that we are doing for that specific expression. All right. When we are evaluating expressions, we're going to substitute a value in for the variable and perform that specific operation. So for examples A and B in this case, we want to evaluate the expression when y equals 12. So all I'm going to do is I'm going to type in -3, and then in parentheses, I'm going to replace y with 12. Now all I have to do is do the operation, which is multiplication, -3 times 12, and that gives me a -36. Looking at B, it means that I'm going to substitute in y for 12, and 8/12 is not in lowest terms, which in lowest terms is 2/3. Okay. Go down, we have some word problems, so let's try to tackle these word problems. I'm going to give myself some more space. All right, here I go. The example is telling us that you want to save money to buy a tablet for school. With this tablet, you can purchase 10 apps, and you get at the last 5 apps for half price. The average app costs $250. If the tablet costs $225, and you base the cost of the apps on the average, how much should you budget? So first thing we have to figure out is we know that the tablet is going to cost $225. And I know that I want to buy 10 apps. And what they told us is basically the average app costs $250. So, and the last 5 apps are half price. So the first 5 apps are going to cost $2.50. $2.50. The last 5 apps said were half price, and so 250 divided by 2 is $1.25 each. I'll just put down each. So the first 5 apps, we're going to say 2.5 multiplying by 5, so I'm going to take 2.5, which is the price, multiplying by 5, and you get 12.50. And then the last 5, you're going to take a $1.25 and multiply them by 5. So 1.25 multiplied by 5, you get 6.25. And when you add them together, you get a total of $18.75 you're going to spend on the apps. So your budget is going to be $225, which is the tablet itself, and then $18.75 for the apps. So that's going to give you to a grand total of $243.75. That's how much you're going to have to budget to afford the tablet and those 10 apps. Next thing we're going to talk about is excuse me, exponential expression. Now, exponential expression, we're going to have a little value on the top right corner of our term. In this case, it's the number 2. This thing, this value 2, has a name. It's called the base. And this value here, it's called the power, or the exponent, which is written right here. And when you see a value to some power, it's not, like in this case, it's 2 to the 3rd power. That does not mean 2 times 3. It does not mean that. 2 to the 3rd power means 2 times 2 times 2. So there's 1, 2, 3 terms of 2, and that ends up equaling a value of 8. So I want to write the expression in extended form, and I also want to write it in words. So in this case, the extended form is like the expanded form. So the extended form is 11 times 11. If I were to write this in words, it would be 11 to the 2nd power. I could also write 11 squared because it's to the 2nd power, okay? If I look at B, it's going to be 0.5 times 0.5 times 0.5 because it's, or 5/10 to the 3rd power. If I were to write that in words, it would be 5/10 to the 3rd power. You could also write 5/10 cubed because anytime you have a 3rd power, that's also to be cubed. Okay? If you look at C and D, they're very similar, but they're very different. What the big difference is the parentheses. And do parentheses really make a difference? Absolutely. The reason for that is because the parentheses are made for both the 2 and the 3 to be a power of 4. So essentially, this is like 2 to the 4th power divided by 3 to the 4th power. But how you would write this in expanded form, it would be 2 times 2 times 2 times 2 divided by 3 times 3 times 3 times 3. And in words, this would be 2/3 to the 4th power. For D, the exponent's only attached to the 2. So if I were to write this in expanded form, it would be 2 times 2 times 2 times 2. That would be to the 4th power, but the 3rd does not. So that's the big difference between parentheses in the exponent and no parentheses. And this one would be 2 to the 4th power divided by 3. Okay? Another thing that makes parentheses really, really important is if you have a negative base and a positive, or I'm not sorry, an even exponent. So here, I have parentheses contained with the -4 squared, and on F, it's just -4 squared. Here's where the difference happens. So say I'm going to break this up. I could say that negative 1 times 4 is negative 4. And here it would be squared. Because of order of operation, I must do the inside of the parentheses first before I perform the exponent evaluation. So it basically turns back to this value here. And this value in expanded form is just negative 4 times by negative 4. Negative 4 times negative 4 makes it a positive 16. If I looked at f, which they don't have it, if I bring it to negative 1 times 4 and I square it, since there's no parentheses, the next step is exponents happen before multiplication. So then I have this negative 1 multiplied by 4 squared, which is 16, and then this becomes a negative 16. Okay? So that's the big difference when it comes to parentheses and non-parentheses. You must be very, very careful. Last thing we're going to talk about is area and also volume. Area of a square and then the volume of a cube. If we take the area of the square, the amount of space a two-dimensional plane covers makes a square. And if we all know that each side is equal on a square, so if it was a distance of s, I know that the area of a square will be s squared, whatever that may be. If I looked at volume, it's the amount of mass a three-dimensional object takes up. Since this is a cubed, both length, height, width are all the same. And if they were a distance of s, the volume of a cube would be s to the third power. Okay? Let's take a look at some examples. It says, each side of a square garden takes up 24 feet. You are going to buy fertilizer for the garden, but before you purchase it, you need to find the dimensions of the garden. What is the area of the garden? So they're telling us that it's a square garden and it takes up 24 feet. So they're telling me that I have a garden and each side is 24 feet. I know from its area is s squared. Well, s in this case is 24. So I need to find what 24 squared is. 24 squared equals 576 feet squared. Okay? Here, it's kind of a piggyback to this problem. It says if the fertilizer costs $1.75 per pound and each pound covers 64 square feet, how much will you spend total on fertilizer? So it says each pound is $1.75 and it covers only 64 square feet. So we have to ask ourselves this. How we have to take the 576 square feet, which is the total square footage of our garden, and I'm going to divide it by 64. Because 64 is one bag. That's how much it covers. So if I take 576 and divide it by 64, I get 9. So that means I'm going to need 9 bags. But the question is how much will you spend? Well, if I need 9 bags, and each bag costs $1.75, 9 times $1.75 will give me $15.75. Okay? And that is being able to evaluate expressions. Hope this helps. Until next time.